Hey gamers! I know that you're all busy getting your #1 victory royales, playing on your Xboxes and Nintendos, but I come to you with a very serious problem, and that serious problem is today's calculus situation. Now, the younger generation being so busy with their Goombas and Pac-Mans, they don't realize how far behind they're falling in common everyday math. I'm going to talk to you now about how to put calculus back into your everyday lives. Suppose that you're holding your cone cup of tab, playing the epic video games, and suddenly the volume of the cup starts increasing so much that you need to rapidly dilute it lest it overtake your immediate existence. In my TED Talk, I'll help explain how to fix this problem. Back to the studio.
Film now. Okay, so this problem starts off with a rather simple volume equation. So we know, so we see the height and radius, the toaster, the height and radius. The height we know to be 5 centimeters, radius is 2 centimeters, you know, tiny little cup you can hold in your hand. H prime is equal to R prime. In this case, height prime is equal to the radius prime. These represent the rates at which they increase. They are the same. They increase at the same rate. We know that the volume of a cone is 1/3 pi r squared times h, and we know, like just formulaic, we know that that r prime is 1.5 centimeters a second. Every second it'll increase 1.5 centimeters. So now we're just kind of sitting here in silence. If not for that elevator music that's so obviously in the background. There we go, cleaning. So, V prime equals pi 2/3 r times dh over dt. Now, for this we had to take the derivative of the volume equation, and for variables such as r and h, similar to using h in our equation, similar to using y in our equations, when we take the derivative of a variable as such, you can skip straight to just simply calling it h prime or r prime because the math works out. I need to stick up with this video so I can't go into full depth. But meanwhile, the r squared, we take the 2 in the squared and bring it over to the 1/3, multiply it by the 2, which gets us to the pi 2/3. And then once we plug in, because h prime and r prime are the same, we can just square that sucker right there, which is why when we plug it in, we'll equal pi 2/3 times 2 times 3/2 squared equals v prime. So I believe it's being calculated right now. So all we have to do is sit here and listen to the non-existent elevator music. Thus, V prime equals 9.4248 centimeters cubed. Okay, it's gone. Never mind. And that is the rate at which the volume will be increasing. Now, that's normal related rate problem, right? You have all the different pieces of it. It's kind of like a physics problem. There's just one or two things that you have to find, and all the other things help you get there. We already knew all the rates, all we had to figure out was the rate of volume. Well, now that we have the rate of volume, let's do something fun with volume. So now the prompt was, of course, that our cone cup here, tiny cone cup 2x5, is expanding. So how can we fill this thing with water if it's expanding? Well, we just need to find how long it's going to take, because as long as the water is at a larger rate than our friendly volume rate is, which, look at that, fancy that, it's at 1.57 is W prime, the rate of the water. That's 0.07 larger than the rate of the volume. So normally Normally the equation for the volume that we figured out was that volume over the weight of water would equal T, the W prime as it is, would equal the time. But in this case, because the volume is increasing, we have to add the rate of volume to time plus the original volume, and that'll equal the time times the rate of water, because of course the water is increasing, the volume is increasing. Which then when we work it with algebra, isolate times as a variable, and solve for it, we get that. Good job.